Hello dear viewer, today we will be taking a look at the Paludarium Ecosphere, my magnificent cube of life, which I accidentally forgot to talk about for 4 years, even though it's easily one of my coolest experiments. Today that changes. Since this might not be a familiar project for many of you, let's start with a bit of history.
For those of you that might not know what a closed ecosystem is or how it works, I will try to explain it very briefly. It's essentially an ecosystem that is completely sealed off from the outside world, and therefore all the ecological processes need to happen inside the ecosphere, and it has to be self-sufficient. For instance, all the plants, algae and other photosynthetic organisms use carbon dioxide or other similar molecules to produce sugars with the help of sunlight, with the energy of sunlight. And in the process they also produce oxygen. The oxygen is then actually used by animals and other microbes, bacteria, to burn the sugars, essentially eat, through which they get energy, and as a product they produce carbon dioxide, which is then used again by the plants. And if the animals die or the plants, they can be recycled in a way so that all their organic molecules can be used again by other animals. So that is, in a very brief nutshell, very oversimplified, how a closed ecosystem works. So now you know.
If you're not interested in history and want to see the current state, you can skip to here. But I do think it's interesting. Alrighty then. 5.5 years ago, my dad helped me turn this aquarium into a paludarium, with a dividing pane of glass for the terrarium and aquarium part, and a ledge above the aquarium for more soil and land plants. It had to be filled, of course, so I took some plants from the really wet part of a local park, as well as some sediment and water from a pond. Remember cow duck? What a legend. Assembly time! I added a Cryptocoran wentii and a Hygrophila polysperma from my tropical aquarium to the aquarium part. In the terrarium part I planted the plants from the park, as well as a spider plant and some grass. I didn't plant anything on the terrarium ledge. Let's look at what lived in the aquarium part. Here we have a lesser water boatman, together with daphnia and copepods. This is a chironomic mosquito larva. Here we have a bladder snail surrounded by daphnia. There's quite some hydra hunting on all that is small. Here we have a bunch of tubifex, aka boogieworms. This is after a week, by the way, and look, one of the hydra got massive. Here's another bladder snail. There's quite a few of those, and also some very cute water mites. Weirdly, it took a week for the ostracods to show up. At this point, the paludarium is not shut airtight yet. The big plant grew even bigger. Unsurprisingly, the terrarium ledge was still empty, but the grass was growing. There was also a lot of root development and underground bebe plants. So that's the Paludarium Ecosphere after a week. After a month it had been sealed airtight, after the addition of some springtails and moss. This is an ex-chironomid larva because it's an adult now. At this point the terrarium got completely overrun by aphids, and the big plants seemed not to be liking this invasion. After a month, the leaves that were in the aquarium part were really starting to decay. At this point, a leech appeared. I'm always so mesmerized by their movement. Over yonder, on that there leaf, is a water boatman nymph. Also after a month, a new crustacean showed itself for the first time, an aquatic isopod, Acellus aquaticus. In the terrarium we see that almost all the grass died, and the big plant was almost dead. but the creeping Charlie had a lot of new leaves and the spider plant was still looking great. And a new blade of grass did grow. So that's the Paludarium Ecosphere after a month. This is our cube of life 4 months after being closed. In the terrarium we see that the spider plants have grown a lot, and the creeping Charlie also had a bunch of new leaves. The big plant didn't survive the aphids and has been completely cleaned up, presumably mostly by the springtails. At this point the grass seems to have completely disappeared. The elevated terrarium part was getting green. There was now moss and algae growing, as well as 2 tiny plants. There was also something growing from the top pane of glass, I think some kind of algae or fungus. Let's move on to the aquarium part. Well, as you just might be able to tell, the aquatic isopods have been busy the past 3 months. Just 3 months earlier I had only seen one, so this is quite a change. They must have liked it in there. There were also a bunch of these black dots near the water surface. I still don't know what they are. Maybe duckweed cysts? Look, it's a bebe springtail. Here is that leech again, or another one, who knows. And a tubifex worm, and a bebe isopod. And a big isopod. Here we have a tiny little copepod. The very attentive viewer might have just been able to make out that there is a lot of orange algae growing on all sides of the glass. Pretty, but it also makes it hard to look inside. Something interesting is the sheer amount of critters, ostracods, copepods and isopods, that manage to get inside the tiny bit of water held in place by capillary action between the glass of the elevated terrarium bit and the outer pane of glass. How'd they get up there? So that is a live cube after 4 months. A month later, the Paludarium Ecosphere was feeling the effects of spring. The warmer temperatures caused a lot of water to evaporate, which condensated on all the glass parts. This resulted, pretty much, in rainy conditions in the glass cube. It was raining! The longer and wetter days meant that the plants, especially the creeping Charlie, were doing well. In fact, one of the runners managed to bridge the gap and settled on the elevated terrarium part. The spider plants were covering almost the entire surface of the cube. The daphnia population was increasing and a mystery plant grew in the aquarium. There was also a lot of life in the water droplets suspended from the glass lid of the box. Here we have an Enchytraeus worm and a bunch of tiny microbes, stentors I think, and even a springtail. So, 5 months old. 10 months later, it looked like this. At some point in the previous months, the silicone seal started to degrade a bit, so I patched it from the outside. The crypts were looking good. The glass had become crystal clear again. Interesting how that works. There's loads of hair algae on the sunny side though. Somehow, at this point, some duckweed started growing on the water surface. This copepod is using a duckweed root to rest. And look at those cute little springtails walking on the water surface. The aquatic isopods were still doing fabulously. At this point, the creeping Charlie had completely colonized every corner of the cube of life. Not just the terrarium part, mind you, it's even growing underwater, though with limited success. I mean, just look at those beefy roots. The spider plants are still doing fine, and there's a lot of moss growing underground against the glass. At this point the grass has returned and is growing sparsely all around the terrarium parts. There's also a bunch of really tiny mites roaming the glass and the plants. And the Enchytraeus worms are still present. And that's about all I've showed of this project. However, it didn't just disappear. To recap, here it is at the start, after a week, after a month, after 4 months, after 5 months, and after almost 1.5 years, over 4 years ago now. I did film something in between then and now, so let's look at that. Almost 2 years ago, in the middle of summer, this is what was going on. There was a lot of evaporation and the entire cube was very moist. 2 different kinds of grasses were growing prolifically together with the creeping Charlie. There was also a lot of green goo on the glass, rotting plants and maybe algae as a result of the moisture. The creeping Charlie was also growing straight into the water, where it existed alongside the cryptocoryne. In the water, a lot of daphnia can be seen, but that's about it as far as the fauna goes. All other critters, including the isopods, seem to have disappeared. A lot of water from the aquarium wound up in the terrarium due to condensation. And there's even a tiny little copepod in there. This is about a year ago, so 3 years after the last video about this project. There's not that much to see, except that there are still a lot of daphnia present, and the isopods decided that being extinct wasn't their cup of tea after all, so they returned. The water level in this aquarium dropped a bit, and there's a lot of duckweed growing in one corner. There's a lot of moss and creeping Charlie growing throughout the terrarium parts, but the grass and spider plants seem to have died. What I wanted to show here is that a lot of the water from the aquarium seems to have ended up in the terrarium, probably due to the quote-unquote raining, and that it is therefore very wet. But you mostly see me. The elevated terrarium is also very wet. Can you spot all the tiny springtails? This was about 2 months ago, and I actually had to move the paludarium. Safety first, of course. Unfortunately, I couldn't prevent some of the water from the aquarium sloshing around and into the terrarium. After the move, I noticed that there was a small leak in one of the seals next to the terrarium part. Here's a first impression of what it looks like right after the move. We'll look in more detail shortly, of course, but most noticeable are the dropped water level, the large amount of duckweed, and the very dominant presence of the creeping Charlie. In addition to the raining, the sloshing around in the car completely flooded the terrarium. Just look at all those boogie worms. Interestingly, after 5.5 years, I noticed an inhabitant of this ecosystem that I never noticed before, an earthworm, and also cute and tiny springtails, but those aren't new. This is quite a big earthworm actually, and it is roaming around on the terrarium ledge. That's pretty cool. It's interesting that I never noticed it before, but to be fair, I haven't paid close attention to this ecosystem the last few years, and rarely at night. I didn't see one in the beginning either though. It's possible that some dormant eggs were present in the soil and were triggered to hatch at some point due to the continuously increasing humidity of the soil. Or they were just always there and I never noticed, also a possibility of course. Here is a smaller one in the actual terrarium. Alrighty then, let's take a close look at how it is now. This is the live cube at 5.5 years old. Here's the aquarium part, still teeming with life, and where, miraculously, the daphnia are still present in large numbers. In my experience, daphnia are almost always one of the first species to go extinct in closed ecosystems, so it's really special to see them do so well in here. While copepods usually fare way better in closed ecosystems, 5.5 years is still quite impressive. It is hardly a surprise that the ostracods, our little sea shrimp, are doing well in here, but I'm still very glad to have them around. The boogie worms are also still here to keep the party going. Look at that dance! You've seen them a few times already. They are quite hard to miss. They are the aquatic isopods, Acellus aquaticus. I've had those in, I believe, 1 or 2 other ecosystems, and there they didn't survive for a very long time, so it's great to see them doing this well for so long. Aren't they the cutest? Here's a nice back-to-front overview of all that lives in the aquarium. As you can see, there's a lot of activity in there. In previous clips we saw that there was some duckweed on the water surface. Slowly, very slowly, we saw how it reproduced and spread somewhat over the water surface. By now, it has completely covered the entire water surface. It's fascinating that after not being present for quite some time in this ecosystem, it did start growing. And now, after many years, it is about as present as it can be. I wonder how much this changed the ecosystem. I can imagine they produce a lot of oxygen and take up a lot of carbon dioxide, and their roots will be filtering the water. Functions that they couldn't perform before due to their absence, but then again, there have always been plants in and out of the water performing those functions, so maybe their relative contribution increased but the overall productivity of the ecosystem didn't. The layer of duckweed is pierced by some creeping Charlie, which also grows underwater. It does actually grow underwater, but the leaves are much smaller. So, the aquatic isopods. You might know them as pond slader, water louse, aquatic soapbug, water hog louse or cressbug. In the Netherlands, some people call them waterezeltje, which means little water donkey, which I personally think is the best name out of all of them. These little water donkeys are quite big animals in terms of closed ecosystem inhabitants. They can get up to 15 millimeters long, about 2/3 of an inch. They can live up to 1.5 years, depending on the temperature of the water, and they reach sexual maturity after a few months, so there must have been many generations at this point. That was kind of obvious, of course. At first we only saw one, which must have reproduced. And 2 years ago they seemed to have disappeared altogether. I still don't really know what happened there. Unfortunately, at that point in time I wasn't paying much attention to it, but there must have been at least one adult left hiding somewhere. These little water donkeys keep their eggs in brood pouches underneath their body, so I don't think there could have been just eggs still laying around somewhere. Even though these critters didn't last that long in my other projects, it would make sense that they do. They are a very hardy species which can be found in a lot of gross freshwater environments, and they're quite resistant to many pollutants. They eat just about anything they can find, so plenty of food, and in this environment they lack any natural predators. I just think they're so cool. Look at these very aggressively orange-yellow algae on the glass, by the way. Isn't it interesting how sometimes one type of algae is growing on the glass, and then suddenly another type of algae, or no algae at all? What's going on there? These ecosystems are just so peculiar. So that's pretty much the aquarium part. But there's more to this cube, of course. We also have the terrarium parts. It is looking pretty green. We can see quite some grass growing, quite a lot actually, which is nice to see. It's interesting that the grass is doing so well, because it struggled right at the start of this project and has disappeared from time to time. Here we have some creeping Charlie, a name you've heard a bunch of times, Glaucoma hederacea. There's also quite a lot of moss growing here. On the sides of the glass you can see a lot of moss growing upward. It's looking quite gross, the glass, very moist. This is not the moss I planted in here, by the way. That died pretty quickly, so this must have been some moss that was present in the soil in some shape or form. I guess it's really liking the increased humidity, which is actually true for all the plants that are still growing in this paludarium. Creeping Charlie is also known as ground ivy or gill over the ground. Of course, there's also the terrarium part, which is elevated above the aquarium part. It's mostly colonized by the grass and a plant you might also know as eelhoof, tunhoof or cat's foot. It looks a bit like a jungle but it's kinda gross. No, wait. It looks a bit like a jungle. It's kind of gross though. There. That's better. The leak is fixed, by the way. There's of course also critters living in the soil, mostly on the ledge by now I think, because the rest is pretty wet. Here we have a baby rainworm, and here we have something else. Like I said, the terrarium part itself has gotten pretty wet. Over the years we've seen it slowly start to fill up due to the raining action. Moving it in the car also caused some water to spill over, so the terrarium kind of turned into an aquarium with just really thick sediment. As we know, where there's water, there is life, so let's see what that life is. Here, in the smaller puddle of water, we have some little sea shrimp. 2 years ago, I could see that there was a teeny tiny copepod in there. How it got there, I have no clue. Now it's filled with quite a lot of animals. The most easy explanation is that they got in there due to some water splashing over from the aquarium. But since there was also that one copepod in there earlier somehow, I can't know for sure. Unfortunately, I didn't take a good look at it before moving it. It might be a bit difficult to see from the video. The daphnia and copepods in here are really tiny. In the larger puddle of water, there's also moss growing, and even duckweed on the water surface. The daphnia over here are quite a bit bigger for some reason, and it's actually the ostracods that seem to be smaller. The copepods are equally small. I really don't know what to make of this. At some point, which took longer than I care to admit, I realized that I could also turn it around to film on the other side. The side facing the window and receiving the most light. And there really is a difference. This plant, which you might know as field balm, runaway robin or creeping jenny, is growing a lot on and towards this side. There's even more moss growing on this side as well. On this part of the terrarium ledge, the soil fell into the aquarium, presumably due to the move, but maybe the growing roots pushed it away. From this angle you can nicely see just how much of the terrarium plants have grown above and even into the aquarium. On the sunny side of the aquarium there's a lot of thread algae growth. This makes sense of course, as there is much more light available on this side. It blocks a lot of light from penetrating deeper into the aquarium, and we don't see it growing there. The isopods, which eat just about anything, like snacking on this algae. In this corner there's a very dense patch of thread algae for some reason, and also a submerged bit of duckweed. Oh no, I got distracted by a little water donkey again. You wouldn't believe how often that happens. This is difficult to see, but something is burying into the sediment, and I don't think it's another tubifex worm. It could be ostracods or small isopod, or something else entirely. Well, it took some time, but that's about it for the Paludarium Ecosphere. I would say it's doing pretty good. There's a lot of biodiversity in the aquarium part. We've got the isopods, tubifex, ostracods, copepods, daphnia and algae, as well as duckweed, which is quite a lot for such an old ecosystem that has been completely closed for years. What I haven't told you yet is that all the aquarium plants seem to have died by now. And interestingly, despite its high biodiversity, the bladder snails disappeared rather quickly, even though they're usually one of the most hardy species. The terrarium part isn't necessarily extraordinarily biodiverse, but it's certainly not doing bad at all, especially considering that it pretty much got flooded over time. At this point, the water level on both sides of the divider is equal, and I suspect it will stay that way as both parts now experience equal evaporation and precipitation, but I guess we'll see. So, why is it doing so well? Well, there's a couple of options. The first one I want to get out of the way are the leaks. There's been 2 times in the history of this ecosystem that it experienced a small leak. These leaks were sealed quickly, but it does mean that at 2 points in time there has been a brief and small connection with the outside world. I don't think this will have mattered much, as like I said they were small and there haven't been any leaks for a few years in a row, but still, it's another variable. One might think that the significantly lower water level in the aquarium could be explained by evaporation through these holes, but there was a lot of air and empty space in the terrarium part where I think it all went. Secondly, this ecosystem is the biggest closed ecosystem I have ever made, so far, and I do think that size matters. I'm planning to do experiments concerning that somewhere in the future. And lastly, this is the only closed paludarium ecosystem I have ever made. In other words, the only one with aquatic and terrestrial parts. I think the interaction between land and water should not be overlooked. I mean, in nature, a body of water is almost always surrounded by banks and terrestrial organisms. For instance, maybe the terrarium parts are producing more oxygen than consuming it, and the aquarium is consuming more oxygen than it produces. Together, as a whole, the ecosystem is then balanced for its oxygen requirements. This is just an example, I don't know if it's actually true, but it might work that way for a number of variables. I'm actually planning to make another paludarium, but several times bigger, once I reach 500,000 subscribers. So make sure to share this video with every single person you know, even the person you secretly have a crush on. You never know, they might appreciate it. Well, that's it. I really hope you enjoyed this video and I will see you again soon. Bye bye.